Welcome to the course on computer network. I am Dr. Sashikla Devi, School of Computing, Shastra deemed to be University. In this lecture, we are going to discuss about medium access control protocol. So this lecture covers the definition about medium access control protocol, different approaches of MAC, selecting the suitable MAC protocol for the specific application, a simple two-station MAC example, analysis of a MAC in terms of throughput as well as delay. First of all, medium access, the medium is nothing but a common broadcasting channel. The channel carries data. Shared medium is fundamental for developing the broadcasting type network. Broadcasting type network in which all the station will receive the data whenever one of the station transmit it. For example, here we have M station. All these stations are connected by the common broadcasting channel. If any one of the station transmits the data, that is, it's possible to receive the data by all the station. So there are two different type of network. One is a broadcasting type network, another one is a point-to-point network. In a point-to-point network, the data to be transmitted to the specific station. In the broadcasting type network, for example, a station connected with a channel connected with M stations. Here these are station. Station is nothing but a device or computer capable of transmitting the data. Let us assume this is station 1, station 2, station 3. And this is nothing but a common channel. The channel carries data. So this type of network is known as a broadcasting type network because whenever the station transmits the data, passes through this common channel. So broadcasting type network carries data which can be transmitted to any station in this particular network. So shared medium is fundamental for designing the broadcasting type network. So this is one example for broadcasting type network. We have M station. All the station can transmit and receive the data through this common channel. And a broadcasting network, it is somewhat inexpensive to develop because for wired network, the broadcasting network is made up of twisted pair or coaxial cable or fiber cable, and for wireless it's based on short range radio communication. The important problem with this particular approach is whenever the station transmits the data is visible to all the station. So we need to solve the problem of collision and contention. So the collision problem to be resolved by using medium access control protocol. MAC stands for medium access control protocol. It can also be referred as multiple access control protocol. So there are different techniques that are available for medium access control. Broadly it is classified into two types. One is a static channelization, static medium access control protocol. Another one is a dynamic medium access control protocol. The static allocation, the station to be partitioned, the channel to be partitioned to M different station. For example, let us consider a frequency division multiplexing. In the frequency division multiplexing, the available frequency band is divided into a subband. For example, first 4 kilohertz subband, second 4 kilohertz subband, and so on. This particular frequency band is allocated to one station. The second frequency band is allocated to another station. So each and every station will get a separate frequency band. So this type of allocation is known as partition allocation or static allocation because the frequency band is allocated to the station in the static manner. And each and every station will get a dedicated bandwidth. So, station 1 will get the dedicated bandwidth of 0 to 4 kilohertz frequency. Station 2 will get the dedicated bandwidth, dedicated frequency from 4 kilohertz to 8 kilohertz and so on. One example satellite transmission, we will discuss about this satellite transmission in the later slide. The second category of medium access control protocol is dynamic allocation. So, the dynamic allocation further classified into two categories. One is a scheduling type approach, another one is random access approach. In the scheduling type approach, each and every station will take a turn, its own turn. So, whenever the station is ready with the data, the station should request for the slot to transmit. For example, here I have 5 stations. All these 5 stations are connected with a common channel. Station 1, station 2, station 3, 4, 5 and so on. Now, if any one of the station wants to transmit the data, so it can transmit the data during the stage its own turn. So, the turn will be allocated to the station based on the request. This type of approach is known as scheduling approach. One example, Ethernet local area network, that is 802.3 standard, or token ring approach. Last category of dynamic medium access control protocol is a random access protocol. So, in the random access protocol, the station can transmit the data whenever it is ready with the data. For example, if station 2 wants to transmit the data, if the data is ready, station 2 can transmit. But the problem here is there is a possibility of crash. 2 stations can transmit the data at the same time, that particular problem to be resolved. But one advantage of random access protocol is very easy to implement because there is no need for coordination among the station. So, there is a loose coordination among the station. There is no need for centralized control, and it is a very simple way of implementing the medium access control protocol. So, when the station is ready, it can send the data if the channel is free. If the channel is not free, wait for some random period of time, again sends a channel. If the channel is free, it can transmit the data. If collision occurs, the same data to be retransmitted. One example is Ethernet standard. The first is static channel allocation. One example is a satellite channel, satellite communication. So, here there are 4 base stations are available. The 4 base station can communicate with the satellite. So, the frequency is divided into different subband. So, the base station 1 can transmit the data to the satellite by using the uplink frequency band F in. The satellite can transmit the data to all the station by using a downlink frequency. So, here the common medium is air. Air is a common medium here. So, the channel, air common medium, air is used for broadcasting the data to the different base station. But this is based on static allocation scheme in specific frequency division multiple access scheme. So, every station will be allotted with different frequency band. So, second type of medium access control protocol is scheduling approach. One example is a token passing. The stations are connected like this. See here, there are M stations are available. So, the stations are connected in the circular approach. M different stations are connected by using circular architecture. This is a channel and these are the station. So, whenever the station wants to transmit the data, it should wait for its own turn. Now, here in this particular protocol, the turn is nothing but a token. So, the station should receive the token before transmitting the data. Now, for the entire network, there is only one token. The token should be passed by one station to another station. Whenever the station wants to transmit the data, the station should acquire the token. After acquiring the token, the station can transmit the data. After transmitting the data, the token to be handed over to the next neighboring node. So, the token will travel in this direction, that is clockwise direction. So now assume we have an example here. Station 1 wants to transmit the data. If station 1 wants to transmit the data, the station 1 should acquire the token. Assume the token is available with the station M. So M should hand over the token to 1. So now the station 1 receives the token. After receiving the token, the station 1 can transmit the data. But here in the token ring approach, the data should also travel in the same clockwise direction. So the station 1 first acquire the token. After acquiring the token, the station 1 can transmit the data to M through this circular approach. So data will be transmitted from 1 to 2 and then it passes through 3, 4, 5, finally it will reach M. So this type of architecture is a token ring based architecture. So in this particular architecture, the token will travel in this particular circular network. Whenever the station is ready with the data, it should wait for the token. After acquiring the token, the station can transmit. And another type of random access protocol, another type of medium access control protocol is a random access protocol. A best example for random access medium access protocol is IEEE 802.3 or Ethernet standard. So in the Ethernet standard, the computers are connected by using bus-like architecture. Now this is a common bus channel. The computers are connected like this. Let us assume I have some stations. M number of stations are available. So each and every station can transmit and receive the data. So for example, station 4 wants to transmit the data. Now the station 4 sends a channel. If the channel is free, the station 4 can transmit the data. Now 4 just transmitted the data to 1 as well as 5. Now for this message, the station 1 as well as M to be responded back to 4. So 1 as well as station 1 as well as station M has transmitted the data at the same time. So if it happens like this, there is a possibility of crash because the data from 1 is collide with the data from 3. So this problem is known as collision. If collision occurs, none of the station will receive the data. So again, station 1 and station M wait for some random period of time and then it try to retransmit the data again. So in the random access protocol, overhead of the random access protocol is there is a need for retransmission in the event of crash or collision. So there are different multiple access protocols are available like channelization, random access, scheduling. What is a specific medium access control protocol that should be selected for the specific application? So some of the things, some of the criteria to be considered to select the suitable medium access control protocol. First thing, we have to analyze the type of application. Second, we need to decide about the number of contributing stations in the network. So application and scale plays a vital role in selecting the specific medium access control protocol. For example, first of all, we need to decide about the type of traffic. So sometimes the traffic may be the constant steady traffic like CBR traffic. Some application may generate the traffic like VBR. CBR stands for constant bitrate traffic. VBR stands for variable bitrate traffic. So in the constant bitrate traffic, all the station needs to transmit the data with a constant interval of time. But the VBR traffic, the station needs to transmit the data with a varying delay. So for constant bitrate traffic, static allocation may be the suitable one. For VBR traffic, scheduling or random access may be the suitable one. Second category of application is what type of streaming data generated by the application. As it is, sometimes it may be the voice stream application. If it is a voice stream application, it's sensitive to delay as well as jitter. So MAC protocol, random access based MAC protocol is not suitable for delay sensitive or jitter sensitive application. And we need to consider the size of the messages also. Sometimes the application may generate a very short messages Sometimes it may generate very lengthy messages. For example, whenever we download web page, the content, the size of the message is somewhat very lengthy. So we have to decide a MAC protocol based on the size of the message also. The last important criteria is fault tolerant or reliability and the cost. Random access protocol, sometimes it may reduces the reliability, it may not be suitable for reliability centric application. So we need to select the protocol based by considering the reliability as well as cost factor. Second category to be considered to design the medium access protocol is scalability. Scalability in terms of traffic as well as in terms of number of user. If the traffic is high, some MAC protocol may be specific or may be applicable. If the traffic is low, a different type of MAC protocol to be utilized. If number of users are high, then we have to select the MAC protocol to support maximum number of users. So all these criteria to be considered to select the suitable MAC protocol. So let me get into the simple example, two station MAC protocol. We have two station A and B connected by the common broadcasting channel. Now A and B can transmit and receive the data through this broadcasting channel. So assume A just started transmitting the data at time t equal to 0. So to transmit the data, A requires TF period of time. TF is nothing but a ratio between the size of the data divided by the channel capacity, L by R. For example, if the size is, if the length of the packet is 1000 bit, 1000 and channel capacity is 1 megabits per second, let it be 1 into 10 power 6. If it is so, the transmission time is nothing but 1000 into 10 power minus 3. So the transmission time is nothing but a ratio between L by R. So TF period of time is required to inject the packet onto the channel. The packet travels from A to B. So that delay is known as a propagation delay. So propagation delay is a time taken by the frame to travel from one end of the station to another end of the station, one end of the link to another end of the link. So the propagation delay is based on two metrics: distance between the station and the velocity of the channel. So it's a ratio between D and V. Propagation delay is equal to D by V. So TP period is required to move the packet from one end of the link to another end of the link. So in this example, let us consider two different cases. In the first case, A wants to transmit the data to B. So A captures this channel first. Okay. Now B should wait for T propagation period of time to completely receive the frame. A has just started transmitting the data at time t equal to 0. B requires T propagation period of time to completely receive the frame. So B does not transmit the data before T propagation period of time, because a T propagation is a time taken by the packet to travel from one end to another end. Consider another second case. Now after transmitting the data, A may transmit another frame, A may be interested to transmit another frame. Now A needs to wait for 2 TP period of time. 2 TP is nothing but 2 TP is also known as RTT. RTT is nothing but round trip time. So round trip time, that is the packet transmitted by A travels from A to B, and then the B's packet travel from B to A. The time taken by A's packet to reach the destination B is TP. Time taken by the B's packet to reach station A is TP again. Now the station A needs to wait for 2 TP period of time to transmit the next frame. So after transmitting the data, the station A should not transmit till 2 TP period of time. So Efficiency of two station example, the station requires 2 TP period of time to transmit a single frame. That means the station should wait for 2 TP period of time to transmit each and every frame. Now consider two parameters. One is transmission rate or bandwidth of the channel or bits per second. The size of the frame is L bits per frame. Now the efficiency is based on two parameters. One is transmission time of the single frame, another one is the propagation delay between the station. So now consider if R is a bandwidth and L is a size of the frame, the time to transmit one frame is equal to L by R, and propagation delay is a time taken by the frame to travel from one end to another end. So now to transmit one frame, the time required to transmit one frame is L by R, but the station should wait for 2 TP period of time before transmitting each and every frame. So I can write like this: the time to transmit one frame is T transmission time, but it should wait for T transmission time to transmit one frame, but every frame transmission time, every frame transmission slot is preceded with idle period, that is 2 times of propagation delay, that is 2 propagation delay. Now if you normalize it, you will get 1 by 1 plus 2 times of propagation delay by transmission delay. So I can still rewrite this as 1 by 1 plus 2 into A, where A is a ratio between propagation delay by the transmission delay. So the efficiency formula is 1 by 1 plus 2A. So this efficiency formula is calculated based on two delay metric. One is a transmission delay to transmit a frame, and the propagation delay taken by the packet to travel from one end of the station, one end of the channel to another end of the channel. So efficiency is based on the simple formula 1 by 1 plus 2A. So the second important parameter related to network is throughput. That means throughput is nothing but the maximum amount of data that can be transmitted over the channel per unit of time. So 1 by 1 plus 2A into the channel bandwidth R. Okay, 1 by 1 plus 2A into R is throughput of the channel. So efficiency is 1 by 1 plus 2A, throughput is 1 by 1 plus 2A times of R. R is the channel bandwidth. So in the MAC protocol, the efficiency of the MAC protocol, the throughput is based on two factors. One is a propagation delay as well as a transmission delay. Now we get into the deeper look of this efficiency formula. 1 by 1 plus 2A, in this the most important parameter A is a ratio between the propagation delay and the transmission delay. Now if you look out A clearly, if A is less than 1, the efficiency will be closer to 100%. That is, if A is somewhat closer to 0, then the efficiency, if it is closer to 0, 2 into 0, this term will be 0, this entire term will be 0. So 1 by 1 is equal to 1. Now the throughput will be 1 into R. R is a channel capacity, a channel bandwidth. So we can utilize the channel fully. 100% utilization of the channel is possible if A is closer to 0. But if A approaches 1, the efficiency will be very, very low. So the MAC protocol is suitable for the network in which the distance between the stations are low. Now we have different type of network. Let us consider the personal area network, local area network, wide area network. So in the personal area network, the distance between the stations are very minimal. So the A will be very, very small. So for MAC protocol is somewhat suitable for personal area network. In the local area network, the stations are separated in terms of meters. So the distance between the stations are in terms of meters, so that the LAN is also the MAC protocol is suitable for local area network, but it is not suitable for wide area network, because in the wide area network the stations are separated, the distance between the stations are very high. If the distance between the stations are high, the propagation delay will be high. If the propagation delay is high, then the A will be closer to 1. If A is closer to 1, the efficiency will be very low. So the channel utilization will be very, very low. So these are the information about medium access control protocol. The alternatively, it can also be referred as multiple access protocol. So the different types of multiple access protocols are available. So this lecture covers only the introductory idea about MAC protocol. In the next forthcoming lectures, we'll discuss about specific MAC protocol in detail. Whenever we consider the MAC protocol, these are the two parameter, two quality of service parameter. The first parameter is a delay, second parameter is a throughput. So the delay to be calculated by considering two things. The actually delay is nothing but the time difference between the first bit of the frames arrives at the source MAC and the last bit of the frame delivered at the destination. This time delay is known as a frame transfer delay. And the second parameter is a throughput, that is the rate at which the medium to be utilized. So this will be referred in terms of this is measured in terms of bits per second or number of frames per second. So to calculate these two quality of service parameter, we need to consider some specific quantity values. R is a channel bandwidth, R bits per second in terms of bits per second. L is the size of the frame in terms of bits. Transmission time is a ratio between L by R seconds per frame, and number of arrival rate is also decided based on I frames per second. Throughput is based on L by R frames per second. So thank you.